All right, algebra people. Differences of squares. This is what we're going to work on now. The differences of squares. Pretty simple stuff set up. Initially, I had a plus sign here. Automatically, I knew wasn't going to work if there's a plus sign there. It's got to be a negative sign in this for this to be a differences of squares. Now, what it means by a differences of squares is within this problem, since this is only a two-part, it's a binomial, I know that there has to be a plus and a minus in here. Why? Because the OI, wipes each other out in this one. It cancels it out, so it's gone, and you're left with just the first and the last of the FOIL method. Okay? Well, I know what the first part is going to be. That's simple. That's an x here and an x here. Well, how do I make 2? Well, how do I make 4? 4 with a perfect square, differences of squares, will be a 2 and a 2, because 2 times 2 makes 4. Now, it ends with a y squared, so they both have to have y's. All you're doing is looking at this. Has to be a perfect square for you to be able to work it out. Has to be a binomial with a negative sign or subtraction in the middle of it. Otherwise, it won't factor, it won't work. So when we do this, we don't need to test the first. X times x is x squared. We don't need to test the last. 2 times negative 2 is negative 4, y squared. We know that. It's the OI, the inside-outside, or the outside-inside. Outside, x times negative 2y. X times negative 2y is a negative 2xy. 2y times x is a positive 2xy. Negative 2xy and a positive 2xy cancel each other out. Now I know that this is the factor or the difference of difference of squares. Okay, now this was number 24 from your homework. As I flip this over carefully, this is number 27. A little more difficult, a little tougher to work out with this one. Why is it a little tougher to work out? There's more crap. There's more crap in this one. There's something I can do in this problem to make it nicer. Where is there anything common in the first part and the last part? Well, I see a k squared here. I see a k to the fourth there. That means I can take k's from both the first and the second part. I can factor them out. But look at the coefficients. I've got a 6 and a 54. Both of those are divisible by a 6. So I can take a 6k squared away from both of them. What's 6 divided by 6? Gone. K squared taken away. You're left with just h to the fourth power. Bring down the minus sign. 54 divided by 6 is 9. Why is that so pretty? Perfect square. 9. Okay. Take away 2 k's, you're left with k squared. Look at this. I don't care about this. This means nothing to me right now. That 6k to the second, you don't exist. This, we've got a perfect square deal here again. We've got a binomial. We've got h to the fourth, which is just an h squared times an h squared. That's simple enough. It's negative here, so I know it's got to be a difference of squares. A plus minus and a 9k to the second. Well, the perfect square that makes 9 is a 3k. Look at this. I've made a difference of 2 squares, 2 perfect squares. H to the second plus 3k, h to the second minus 3k, because h squared times negative 3 is a negative 3h squared k, square, h squared k, wow. 3k times h squared is a positive 3k h squared. They cancel each other out. The OI does. Don't forget to bring down the 6k to the second power. This is your answer. Now, as long as it doesn't say make it equal to 0 yet, as long as it doesn't say that, this is our answer. We have factored this ugly monster out into 2 binomials and a coefficient way out in front here, the part out in front. That's all you're doing on page 502. So let's just stick with page 502 for tonight. We'll go over more tomorrow. If you have any questions from page 488, 496, or 502, just shoot it out to me. Ask me. Send me an email. I am here. Okay? Although all you've seen is my arm, I'm here. So, miss you. Want to see you soon. Bye.